All righty, so here we go, mobile round 2. Some of you may have been in my session yesterday, which was sort of a 101. Consider this a 201 level on mobile DevSecOps. So we're the Brian and Brian show. We are both named Brian, and I'm the Chief Mobility Officer. Yeah, there it is. I'm the Chief Mobility Officer, and Brian is?
I'm the Solutions Engineering Manager at NowSecure.
Also now a Jenkins certified engineer.
Yes, and DevSecOps engineer.
There you go. So you may have seen our stickers running around. We threw the party on Monday night. Thank you all for coming. We really come from this world of how do you build security in from the start. And so what we wanted to do is kind of share what we've learned. So we have a lot of name brand customers, and I put this up really to say that we've tested apps used by over 50 million people, right? So we work with a lot of the largest brands who are producing mobile applications. And so what we've really done is we've taken everything we've learned over the past 4 years and kind of bottled it up here in something we can fit in about 45 minutes. Industry stats are pretty stunning, right? How many people in this room think that mobile app usage is higher than web app usage? There you go, you would be correct, right? And so that makes it very interesting because now the mobile app development velocity has increased, the number of developers and applications getting produced has continued to increase, but we have that problem where there's nowhere near enough security people to try to do it. So we actually started as a professional services company and built tools because we couldn't hire enough security engineers. And so now we've 5 years later built tools that are 100% automated, so you get the equivalency of a pen test, but it kind of runs through the cycle. Now the organizations we work with are ones that really look at mobile as either their core business or a transformational sort of activity, right? If you've been to McDonald's recently, clearly they've changed their business. We're just releasing an infographic today that has business impact of mobile that you can find at nowsecure.com, and it's really interesting analysis of like Bank of America, Starbucks, Domino's Pizza, I think a couple of airlines, and so on and so forth, kind of looking at what the impact is. So when you actually look at that usage, I asked the question, it is stunning that actually in the end of 2017, when ComScore did their last measurement, they showed that the use of mobile application time had exceeded web application time for most age groups, except for the old folks at the end. And this is the end of 2017. Now, we sometimes are with organizations and we sit down and we say, you know, what is your ratio of web versus mobile use? How many people in the room know that answer for your company? That's part of the problem for many organizations. And so mobile might be racing ahead, web might be racing ahead. Sometimes the challenge is simply that all the resources are on web and they haven't gotten into the mobile and understanding mobile and so on and so forth on the mobile tool chain. Sometimes it's the mobile team is off hanging off the side, right? And you got to kind of figure out how to corral them back into a process that meets the cadence in the mobile world. And so this is what we're trying to prevent for you all, right? Don't want to be scary. We want to be positive about the whole thing. This is what happens when mobile pipelines run faster than security, right? All of these guys had vulnerabilities in their apps that were exploitable that should have been found with common, simple testing. Some of them were patch-based, some of them were miscodings, some of them were third-party ad libraries that had vulnerabilities in them, right? So we don't want any of that to happen to you. So what we're going to do is basically take this, millions of apps that we have worked on with our customers and kind of bottle them up into 5 best practices as a learning vehicle for you. And so really what the focus here isn't all about the tools. It's actually about how to bring, dev and security together, right? Welcome to the land of DevSecOps. We have our own internal debate of is it secure DevOps or is it DevSecOps or what have you. The reality is that security ought to be built in. But we have this sort of natural contention where the velocity and speed on the development side is often outpacing security's ability to either work with them or be part of the conversation, or they're simply hanging off the side. We have one very large multinational corporation that I bet half of you in this room work with, and they had such a separation between dev and security that the way security tests the apps is they actually take them out of the AppStore after they're published, and then they test them. And then they provide development with feedback, and then development patches them and pushes them back into the App Store. That's how far the division actually is. Now, over the past, 18 months with these guys? 1 year, 18 months, we've helped them bring dev and security together, and now they're actually testing in line using Jenkins and all that other good stuff. So with that, I'm going to hand off to Brian, who's going to walk us through sort of the big 5 things we've learned that you can take home.
Yeah, thank you. So we'll start off, and this is a big bone of contention that we deal with a lot of our customers. People have been doing web app testing for 20 plus years now. Everyone's familiar with it. We all know, how it happens. Usually a lot of SAST. There's been a lot of challenges around dynamic testing, so everybody's kind of entrenched in that mentality. The truth is, though, they're not the same. And what we want to talk about today is using that dynamic mobile testing, which is very different and actually considerably more effective, to start bridging those gaps, not only between testing methodologies and getting security coverage, but also between DevOps and security teams. I was actually on a call earlier this morning, and we had the head of development for a bank on the phone, and we mentioned the head of mobile security, and there's silence on the line. He was just like, who? I don't know that guy. So we need to start bridging those gaps and making those connections. And we'll talk about how do we actually build this into DevOps. We got to this amazing DevOps revolution. We got to the end, and then we turned around and said, crap, we forgot security. So we're going to talk about how do we bring that in. Then we start talking about building that AppSec factory. So as build speeds increase, release cycles decrease, we have to automate mobile application security. There is no other way. We've talked to groups. We're getting multiple builds a day from a lot of mobile application groups. You just can't scale that with people. You need to leverage that automation, create that factory. And then last, we're going to talk a little bit about scalability. As Brian mentioned, we work with a lot of different applications. We're actually performing about 3,000 to 5,000 pen tests a day on mobile apps. So we'll talk a little bit about what that looks like. So first, talking about the differences in mobile and web. There is this myth out there that mobile and web, you can test them the same way because they're doing the same things. Couldn't possibly be more wrong. So with mobile applications, you are putting out a compiled binary into a public app store. Your code is out there, particularly on the Android side. It is actually very, very easy to take an application from the App Store, reverse engineer it, and get the exact code that was used to program that application. So your code is out there. We actually had someone come to our booth yesterday. We talked with them about their application, and we talked about a particular vulnerability in their application, and our researcher was actually able to pinpoint the method and line of code that was causing the problem that we identified dynamically in about 5 minutes. It's very, very easy to do. Where web apps, on the other hand, there's mostly that just basic front end, that UI. Everything else is kind of gated off. You've got a lot more isolation there. There is no device, so you're running in a browser, right? Where mobile applications, you are inside of an iOS, Android, or if you really want to get weird, a Windows or BlackBerry device. So a lot of just differences in terms of the architecture, and also in terms of the testing methodologies and exploit methodologies that are used out in the world. Great example here is secure connectivity. So how do I access data securely from a mobile application? One of the most common mistakes that we see is not validating host names. And it's very simple. Web apps, you don't have to. Your browser, Safari, Chrome, Firefox, whatever you use, typically handles that mechanism for you inside of a web app. On mobile, there is no native functionality to accomplish this. So we talked to a major financial institution recently. They said, oh, we don't need to do that. We've got that covered. On the phone with them, we showed them how we injected a link to Venmo to send ourselves $10 whenever someone tried to log into their application. Talk about another awkward silence on that one. So it's a very different methodology. There's also just very different exploit paths. So when you're out in the wild, if I'm a malicious actor and I'm looking to exploit your application, I'm first going to download it from the App Store. It's there, it's public, it's already, it's easily accessible. I'm going to download and reverse engineer it. So again, for Android, you're getting back to actual Java code. A lot of people talk about obfuscation, which is an interesting security control, but that doesn't actually fix any problems. It just makes them a tiny bit harder to find. Then we are going to run that application. We're going to load it onto a device, run it, see what happens. What is it doing? What is it connecting to? What is it storing? all of this is available to a malicious actor. There really is, you have to assume that all information is available to that actor. They're going to look for data on the device. So where are we storing data? We find a lot of applications putting things into things like the Android SD card, the iOS keychain, places that really aren't secure. You're not securing data by putting there. Then we talked about data in motion. So if we're not storing the data, how are we transmitting it? How are we utilizing those back-end resources? Typically the same back-end resources that our web apps are using. So it's the same data. It's the same API endpoints. How are we accessing those in ways that might be insecure? Then we can potentially insert ourselves as a man in the middle. There's a really interesting attack chain that was done about 6 months ago where you could actually redirect traffic from the DJI drone app and actually take over a drone this way. Lots of interesting attack vectors. Again, this was just a result of having that information because it was a mobile app. It's probably a lack of expertise, being able to actually secure that and consider those security controls that you might need within your mobile application. And at that point, we've likely got credentials. We've likely got a lot of information. I can insert those deep links to send myself Venmo money. Deep links are also an interesting attack vector for anyone unaware. Deep links are where we actually tell we send it basically, looks like a URL, but it's actually telling the phone to perform an action. So something like open Venmo or send my user key, my keychain information, things like that. So there's a lot of interesting attack vectors there. And then I've got you. So we've got your passwords. We can take over whatever we want. We can modify that information. We did another fun proof of concept where we actually, inside of one restaurant chain's app, redirected them to the order page of their competitor. That was another fun one. And again, a lot of awkward silence in my life. I apologize. So once we've kind of addressed those differences and educated developers, we do a lot of secure development training for developers talking about these differences. Then we start into using dynamic testing to address these gaps. So we hear a lot about false positives, obviously. And unfortunately, in web app testing, it's very, very difficult to do dynamic testing. It has a lot of problems with false positives. In mobile, it's actually switched. So static testing is actually not very effective. So static testing it's not making these data connections. It's not storing this data on the devices. It oftentimes does not have visibility into everything that's included in that binary package that makes it to the App Store. So dynamic testing actually fills a huge gap in mobile coverage because you're able to look at that and consider that entire compiled binary, what's actually being presented to the public out in the world, and you're able to see not just the recipe, but the pie that comes out of the oven. So what we found in mobile, unfortunately, static testing can do certain things, but dynamic testing, and if you look at things like the OWASP mobile testing guide, you'll see that there are no static testing methodologies there for things like data in motion. So those man-in-the-middle connections, accessing all that back-end information, it just doesn't exist for mobile. And we have a lot of data to back this up. So as we were looking at the millions of applications that we've tested over the last couple years, we find a lot of these problems by dynamic testing. And we surprise a lot of our customers who didn't have visibility before, that now we're telling them, hey, did you know you're sending data to Russia and all these different continents? Hey, did you know that you have these SQL injection problems that only happen when the application is running? So it's very surprising for a lot of people. And again, just dynamic testing for mobile is the only methodology that can address this. So what we see out there, talk about kind of overall from this data set that we've generated from all these apps that we've looked at is just insufficient security and privacy restrictions. So there's data leaking everywhere. Everything from usernames and passwords being sent over HTTP to confidential information being stored on SD cards in Android, which can be accessed by anything on the device. So there's just not a lot of testing, not a lot of consideration being done for this. Network connections, we talk about host name validations. We honestly still see a ton of HTTP, just completely insecure connections going out into the wild. Device considerations, so where am I storing data, what am I storing there, how am I storing it, also big concerns. Android has a lot of permissions problems, so what am I giving the app the ability to do versus what am I actually using it for? Again, something that can typically only be checked by actually running the device, or running the app on the device. And of course, third-party risks. So a lot of us are very aware of all the different pieces. Mobile applications actually pull in considerably more third-party components. Often more than half of a mobile application is going to be comprised of third-party components that we often don't have code visibility into. So how do we actually secure this in a DevOps environment? So we know we need to do dynamic testing in order to secure a mobile application, reduce that risk. So we have to put it into this dev tool chain. And where we see that being most effective is right after the binary has been built. So most mobile tool chains will have a tool such as Jenkins, go through, pull in those third-party components, pull in the internal code base, and make that binary and have it ready to go. You have to insert the dynamic testing there. It's actually a lot easier than people think. Dynamic mobile testing can be done in as little as 15 minutes or so. It's about loading the application to a physical device. Unfortunately, emulators do not store and transmit data the way that real devices do, so it has to be done on ARM64 hardware. But it can be done. You can automate it 15 minutes later. You can have a hands-off test of your application and provide valuable feedback to developers with a very, very low false positive rate. Because you're testing on the device, because you're actually running that application, you can actually mostly eliminate false positives from the reports, deliver better information to developers. So we see this a lot. We see a workflow inside of a Jenkins pipeline, generates the binary, pushes it into a dynamic testing tool. You can probably guess which one. Generates a report. The report actually can contain context for each finding because you're actually running it on the device. You actually exploited it to generate the finding. So it's a really cool difference. Again, in mobile applications, you're basically performing the proof of concept as you're doing the testing. So when you send this to developers, you can actually insert valuable information without a lot of noise into existing workflows. So one of the things we focus on a lot is not creating great amounts of friction and just presenting these as bugs. All it is a security flaw. Developers know about security flaws. They fix them all the time. This one just happens to be about security. So then we start to build that AppSec factory. So we work with a lot of our clients to, once we get that automation in place, how do we scale that up? How do we make that meaningful and speed up those feedback loops? So we work a lot with developers, get them used to that feedback, and basically just start getting that automation in place. I don't know if it's a fun fact I love to throw out there. The only time that human productivity has ever actually increased at an increasing rate was the advent of the assembly line, the factories. Not the internet, not the wheel. You can actually see the line curves up during the Industrial Revolution. So we have to do the same thing inside of our DevOps pipelines. And it's actually possible, which a lot of people don't know about. So then we can actually build these pipelines, build these factories, start getting these feedback loops to developers earlier and often, where we can fix these bugs, whether it's much less expensive to do. Think about when we can fix a bug here, or we can fix it, as Brian mentioned earlier, when it's out in the App Store already being exploited. And we want to enable that as far left as possible. So a couple of the approaches that we've actually worked with. We worked with a major auto manufacturer. They had a big push towards electronic vehicles, connected vehicles, and a lot of really great initiatives about building this innovation center. building a lot of innovation within their program that already existed. So we help them shift that left, get their mobile applications that were connecting to cars, connecting to different IoT devices as well, and testing them more early and often. Contrast this with another car company we talked to that were using only static tools for their application that turns the car on, rolls down the windows, locks the doors. That application was actually sending VIN numbers out completely unencrypted. We've also helped a lot of innovation centers. So we see a lot of mobile centers of excellence where there's actually a focused center to bring together the expertise, and embedding security inside of that has been hugely helpful. Getting people talking, getting people relating, having these conversations, having developers and security people sitting next to each other is a huge, huge leap. It just gets them talking. Rather than being on opposite sides of the fence, it gets everybody on the same team. We all want to create a better mobile app. And we might have different ideas about how that gets done, but a lot of that gets resolved when you're in the trenches together. So last, scalability. We talked to a lot of customers about, hey, I've got somewhere between 100 and 1,000 mobile apps. How are we going to test all that? As I mentioned earlier, we have actually built device rigs. So we actually have physical devices. They're on really cool 3D printed boards that allow us to physically manipulate the devices when we need to. We've actually scaled that out. We are doing, as I said, about 3,000 to 5,000 mobile app pen tests a day. That's loading it to a device, going through multiple passes on the application, attempting to log in, doing all the things that a pen tester would, but in a completely hands-off environment. So we actually have a lot of really cool monitoring dashboards. It's allowed us to create a lot of visibility into that scalability, where we can monitor device health, we can monitor app throughput, vulnerability throughput, everything, all of those fun DevOps measurements that people love to see about applications, we can actually also apply to application testing as well, and provide those feedback loops, provide those metrics that would be important to organizations looking to increase their throughput.
All righty.
And I'll leave it to Mr. Reed.
There you go.
To put it all together.
All right. So the other Brian. So what we tried to do is kind of give you the top 5 sort of areas to focus. And there are some amazing things some organizations are doing at the scale, but actually the majority of the time we spend with organizations just starting down that mobile path, right? So a lot of you may be working in a company where you already have mobile apps in the wild. And so that's sort of a let's start with triaging what you have and then figure out how to set it up. Others of you may be just starting mobile initiatives, or there's digital transformation running through your large organization, right? So then it's about how do we set it up in the first place, right? And so working with organizations at different levels, we're about 1/3 services and 2/3 software. We spend a lot of time just trying to help you figure out the best way to go, and often trying to bring those teams together, right, to enable all 5 of these things to happen. And so to go along with this, the fundamental thing that we wind up evangelizing with people is that it's phenomenal that you're trying to move from Agile to DevOps. You may already be in a DevOps mode. Take the time to recognize that the fundamentals of mobile and web are different enough that you need to become educated enough about that difference. And sort of like the earth is flat or the sun revolves around the earth, dynamic testing for mobile is actually better than static, right? So a lot of the default testing that people do on the website is put static in the tool chain. And it's got false positives and other issues, but you get pretty good code coverage out of that. And the reality is that's not true, right? On the mobile side, it's fundamentally different. So we're trying to help people sort of understand that. Making this all work really requires both process and shared knowledge. And so we have resources I'm going to show you in a second that you can bring along to the team. And the number one thing you can do to improve security of mobile apps is build it into the requirements, right? Put it in the user stories, put it in the non-functional requirements, make sure it's actually fundamentally there. Choose libraries that inherently do network communication or file storage that are pre-certified, and then push the mobile development teams to make sure that they reuse that same code. That will help you reduce some of that friction. And so we had our own user group conference earlier this spring. We had 3 or 4 customers up there who consider themselves running in this continuous security state. So they have no pen testers in the company. They have no security people doing testing. They're 100% automated, and the security staff is acting more as advisors on different projects, cross-training, doing investigations when they want to bring in new technology and things like that, which is ideally where they want to be. In a number of the organizations, they've actually embedded the security team into the development team as part of the process. So scaling does happen, so I wanted to give you a quick story. This is one of our customers, so think about it, day zero. They were running what I would call a DevOps environment with a 2-week agile sprint model, and they were doing manual end-of-stage testing. And so they had release delays anywhere from 2 weeks to 2 months because they were doing late-stage testing. Human would then go find some issue. They would go back, cycle through, go through the QA process, and all the rest, and they had substantial delays. So immediately they started using the tools to periodically test. Just let's test this week's build, let's test Tuesday's build, what have you. And they did that within the first month, and that allowed them to collapse the time and move towards an on-demand kind of level. And then after about 6 months for the first tool chain, for the first pipeline, they turned on full automation. Today, they actually grew the security team not to do pen testing, but to embed them into the actual pipeline teams and development teams in order to make that work. So they actually went from full manual to fully automated, no manual testing in 12 months, going through this journey, which is one of the fastest I've ever seen. So it is possible to do that. It all really depends on the commitment between development and security, and they're wanting to get together to do it, and then let some of the tools do the work for you, right? And that's why we assembled tool chain in the first place. So I have some references for you here. I just realized my email address may not have landed in the deck, so I'm going to give that to you in a second. We work with DevOps.com. We do an annual survey of the differences between mobile and web and trends. So there's a download link there for you. We also have a DevOps how-to guide that really helps map out a little more detail from what I just went through, the differences between mobile and web. That's in the middle. We have a bi-weekly DevSecOps newsletter, all things sort of mobile and DevSecOps. So if you're supporting a mobile team or you're mobile dedicated, we encourage you to take advantage of that. We are, of course, over here in a booth. I'm going to give you my email address, which I forgot to put on the slide. So it's really easy. Letter B, letter R, at NowSecure.com. So br@nowsecure.com, or walk up here, take my business card. You send me an email, you get a copy of this, and we can subscribe you into other things, but the main thing is you can have a copy of today's slides by hitting me up in the email. So we have some time left here. We'd love to take any questions from the audience. So can we answer anything for anybody? Sure.
What's been the most interesting bug or issue have you seen in the applications that we saw? I mean, you mentioned a couple of them, but what's been like the most either blatant lack of security or one that's previously the same?
I think my favorite lately has been remote code execution. A lot of people don't realize, but mobile applications have significant vulnerabilities that revolve around zip files. So if you're delivering content to mobile applications in zip files, you have to make sure there's like 4 different things you have to make sure are in place to make sure that's not exploitable. And most people don't even attempt one. So we're actually, a lot of our more our responsible disclosures revolve around that. So I would say that's kind of the most fun and exciting and holy crap, you should throw your phone in a microwave kind of thing. But I think the man-in-the-middle problems are the most common, for sure, that are high severity.
Yeah, so I'll give you the privacy answer to that. So I have a former history in compliance. Privacy is starting to bubble up, right? So I believe that by next year, most organizations should be looking at security and privacy equally. I did a benchmark report last quarter, and some of it made it to the press. And we benchmarked the top 50 apps in 5 categories. So this was based on company revenue. So the top 50 online retailers, right? You can guess like Amazon would be on that list. The top 50 brick and mortar retailers that also have a mobile app, so that would be like Walmart, as a for example. The top 50 travel and hospitality, so that's a mix of hotels, airlines, Uber, that kind of thing, and 1 or 2 other categories. What blew me away was that 75% of them failed GDPR or CCPA, if you understand privacy. What we discovered in looking at it, when you look at the forensic data on the device, a lot of application developers are spewing out PII in an unencrypted fashion somewhere on the device. that an attacker or another app could scrape off the device. So for me, it's not the remote code execution piece. As a privacy and compliance guy, it's horrifying to me that if you gave me your device, the amount of personal information I could find very quickly would be very easy. Now, some of the app developers we talk to would say, well, that's not a big deal. Well, guess what? Over-permissioning of apps on Android mean I can pretty much scrape anything I want, right? And if I can do interception over the air and I can plant something on the device using deep links, then I can get everything off your device, right? So it is entirely possible for somebody to get some of that PII. So that's kind of where my scariness is. You know, those are name brands. I guarantee some of you have those apps on your phone. And what's been interesting is not only is security testing hard, privacy is a little bit harder because there's more gray areas than security, right? So do you really need to collect that person's phone number? Do you really need to persist it in a file? Do you need to put it in that file in an unencrypted place? Things like that. We had an app where they were harvesting everything out of the contact database, packing it up in a zip file, and shipping it home to the mothership. The mothership happened to be in St. Petersburg. So that basically means the Russians have now fingerprinted some 10 to 15 million people who downloaded that application. The app itself wasn't malicious, but it was harvesting everything it possibly could off the device and shipping it up. Now, is that a vulnerability? Is that a privacy issue? Well, we call that a privacy issue, I think. But also thinking about, are you collecting and using the data in the right way? Flashlight, you know, the old joke about the flashlight app doesn't need to know all these other things. We find a lot of developers in their code are capturing more information they need and then not storing it properly, which then creates a new risk. Other questions? Yeah.
What was the
One more time?
What are the two options?
The PWA progress you.
Yes. So it's hard to say. We don't have a lot of data on them yet because not many people are using them. Unfortunately, with a progressive web app, so the question was, are we seeing any differences between progressive web apps and native apps? So progressive web apps they look like mobile apps. They're installed to your phone, but they don't actually run like native code. There's no compile binary, things like that. It's just a web view. Unfortunately, there's a very low adoption rate of them right now because they're missing out you miss out on a lot of native functionality. So like any biometric authentication, you can't do in a progressive web app, for instance. So unfortunately, we don't have a lot of data, but I'm betting if you take two very different architectures and try and smash them together, there's going to be problems somewhere.
So I'll just jump on that real quick. So we did a study earlier this year on low code, no code. So, you know, you may be supporting real pipelines, but there's a lot of these amateur developers using low code, no code. The answer to that is your mileage will vary. So some of the low code, no code platforms have decent security built in. Some of them are horrifyingly bad as well. If you visit our blog, there's a post on our blog about some of the data we found. We didn't name names, but if you have a team somewhere that's using low code, no code, it is a mixed bag, and you need to check with the vendor there. Question?
Yeah, so we are actually testing every app in the US Google Play and iOS app stores. So we have, give or take, about 2 million reports spread out over maybe 1 million applications right now. We can actually provide version history as well for a lot of the applications that release quite a bit of information. So,
and then in terms of your app, right, so you may be part of a development team and your app is in the App Store. In terms of testing your own app, you can use this in a deployment model or a pre-development model, right? So you can plug us into your tool chain. We are a cloud-based service. We have an on-prem option, right? So if you can run on-prem tech, we can do an option, right? Most people want the cloud service because with the cloud service, you get the device farm of thousands of devices. You get immediate updates. If a new vulnerability posts, we very quickly put a test in to find that vulnerability and so on and so forth. But we can support cloud and on-prem as well. I think there was another hand over here somewhere. Someone else? Got it. So how many people are worried about the apps on their phone now? That often happens. I did a session with the National Association of Corporate Auditors and had them mostly freaking out. At the end of the session, we pulled up our AppStore apps, and I just said, give me the name of an app you use. Started pulling up their scores, and it was kind of disheartening. The good news is most people aren't intentionally doing bad things. What we discovered in mobile is that it's just a lack of ignorance, lack of knowledge. in terms of some of the fundamental differences. Developers are in a hurry. They don't always think about everything. Security may not be in the mix enough, and so you get these gaps that occur. These are all easy to fix. 80%, 70-80% of what we find is like 2 lines of code, 1 line of code, throw a switch. They're easy things to fix generally, and they're not very complicated to do. You just got to take time to do it the right way.
Yep.
Yes?
How do you deal with the fact that most customers have to like re-download the app when you patch it? So it's not like with a web app, like you can just send an update now.
Yeah.
And run.
Encourage customers to turn on auto updates. About all you can do for that. Right.
Yeah, I mean, I think that just speaks to why this is so important to get it earlier in that development cycle and catch it before it gets to production, because that cost increases, the risk increases the further you get. We use the analogy of a car, like a car recall. You know, how much easier is it to fix the car before it gets to the assembly line versus the recall of 13,000 vehicles, and then you have to fix them all. So so that's just why it's so important to do this early and often, and then really your production monitoring should just be kind of icing on the cake.
Yeah. So if you've got an existing deployment, existing series of apps, we would come in and triage those apps and give you pointers where to go. We tend to be really noisy early on because of all the stuff we find, and then you kind of get smooth in the machine. I was on the phone with a customer a couple weeks ago talking to them about all our great GUI updates, and they were laughing. They're like, we haven't even logged in. We're just running Jenkins Jira plugged in, and we noticed the tickets went down, so we know it's working. And that's literally what the guy said. So, and then there were questions like, well, what about, new versions of iOS, and what about a new API and whatever? But it was sort of that way, and it's sort of one of those set it and forget it things after you go through the triage cycle, if you don't start with it in the first place. And that's nice because it's kind of like the approval process or the vetting is continuing to happen in the background automatically for you as your development teams continue to evolve the portfolio set.
A lot of our users don't even know there's a UI.
Mm-hmm. We did show you the UI, but normally people are looking at the tickets. So Brian and I will be here for a few minutes. We appreciate your time. Again, my email address is br, as in Brian Reed @nowsecure.com. I'll send you a copy of this if you want. Stop by the booth if you want to see a little bit. If you have come from a company that has an app in the App Store, stop by our booth. If you're curious to see what it looks like, we'll pull it up for you and tell you what your score looks like. So thank you very much, everybody.
Thank you.